Microservices are all the rage right now. You can't have an architectural discussion without this term coming up sooner or later, usually sooner. But what is actually microservices? Well, put simply, a microservices-based architecture is an architecture in which the various functionalities are implemented as separate, loosely coupled services that interact with each other using standard lightweight protocol. To understand the motivation for microservices, let's go back to the pre-microservices days. In these ancient times, applications were built as a monolith, meaning all the functionalities were run in a single process, usually built using the three layers architecture. For example, look at the following diagram depicting a typical HR system built as a monolith. As you can see, all the various modules are always part of the same layer. The Employees API and Salary API are both part of the same service interface. Similarly, the Vacation business logic and Salary business logic are in the same business logic layer, and so on. Monolith systems were and still are extremely popular and are a great way of building small to medium applications. But there are some inherent problems with monolith systems. One, because the application is executed in a single process, then if there is an exception in a single component, the whole process comes crashing down. Every bug, every edge case can render the application unusable. 2. Every time we need to update the application, we need to update the whole code. We cannot replace just a single component because, again, we run in a single process with a single executable. 3. We are limited to one development platform. We cannot combine, say, Java and PHP in the same process, and that might pose a problem, especially in our organizations that have diverse development teams with expertise in different technologies. And last, our compute resources are not optimized. If our application performs some heavy-duty calculations that require a lot of resources, but also performs some lightweight querying, we cannot assign computing resources to the specific code that requires it. We have to assign those resources to the whole application. So, what can be done with all these problems? Well, enter microservices. The microservices architecture claims to solve all these issues. Remember, with microservices, the application is actually a collection of small, lightweight, and loosely coupled services. Each performs one and only one task. So, let's see how this architecture solves the problems described. First, since each service runs in its own process, an exception in a single service will not bring down the whole application. Only the specific service will be impacted, and the rest of the services will continue working as usual. And what about updates? Here again, we benefit from the fact that each service runs in its own process. We can update each service separately and do not need to update all of them at once. A side effect of that is that updates can occur much more frequently since their impact is limited and the testing required for each update is much less than that required for a whole application. The third problem also gets solved here. We can mix and match the development platforms since the services communicate between them using platform-agnostic protocols such as REST. Because of that, each service can be developed using different development platforms, thus optimizing the overall execution of the application. And last, since each service runs in its own process, we can assign resources to each service separately. We can decide, for example, that one service will be developed on 4 virtual machines with 16 cores each, while another one will be deployed on only 2 VMs with 8 cores. Now, let's go back to the HR application and see how it will look like if designed using the microservices pattern. As you can see, instead of a large complex single process, we have many small lightweight services. Each focuses on a single task. Now, this diagram might look familiar to you, and that's not a coincidence. In our case study, we designed the IO2 application to implement the microservices pattern, and we ended up with 4 such services. Each performs a single task and communicates using REST. So microservices is a great pattern and should be considered seriously for almost every web API application. But not all is rosy in the microservices world, and there are some drawbacks that should be taken into account. 1. Microservices-based system can have a lot of services, like hundreds of them. For example, Netflix, one of the leaders in the microservices world after migrating its popular website from monolith to microservices architecture, has more than 700 microservices. When you have such a large amount of microservices, they should be monitored all the time. It's unrealistic to expect that when you have 700 services, everything will work fine all the time. So if you intend to work on a microservices architecture, always include a monitoring solution. Netflix, for example, developed a tool called Eureka that does exactly that. It's an open source tool and you can use it too, or you can use any other tool, but make sure the monitoring is an integral part of the solution. The second problem is the architecture itself. Designing distributed system is a complex feat. Monolith systems are much simpler to design and implement, and you have to be laser focused on each service's functionality to make sure it integrates well in the overall architecture. For example, in one of the applications I've designed a couple of years ago, the development team wasn't familiar with the microservices pattern, so we worked together towards the design of the first service. The end result was a beautiful service that did exactly what we needed it to do, but it took more than 3 months to design, and the service itself contained only 500 lines of code, which is a ridiculous number for a dev team in 3 months. So prepare yourself for a lot of thinking about the design of a microservices-based application. The third and last drawback is testing. Testing a microservices-based application is more difficult than testing a monolith. With monolith, you just call the API and set the expected result. With microservices, some services often depend on other services, so you have to first test the dependent services before testing the services using them. So that was a glimpse on the microservices architecture. It's a very popular architecture pattern and should be in any architect's handbook. In the resources for this lecture, you can find references to some more materials about the microservices pattern, and you are welcome to use them.